Hello and welcome to this tutorial video. In this video, I'm going to discuss how I created a battery management system model using Collimator. Collimator is a Python and cloud-based model-based design software platform. So first, let us look at the vehicle load demand model, which is emulating the charging and discharging current cycles. This is implemented using signal generation blocks like pulse, offset, and some other logical elements. Now we will look at battery management system called controller. Inside this controller, there is a small motor controller model. This model is included inside this to emulate current saturation or current limit that is done by a motor controller. Apart from this, this model contains other usual battery management system modules. One such module is cell current monitoring. Inside cell current monitoring, we are converting ADC value to engineering value, that is current in ampere. We are also doing fault detection for overcurrent and undercurrent in positive and negative direction. This engineering value of the current is later used inside main state machine. Main state machine is implemented using Python script, and the underlying implementation is using if-else loop. Same engineering value of the current is also used to estimate SOC inside fuel gauge monitor module. We are using simple coulombs counting algorithm to calculate SOC. Now we will look at cell voltage monitoring module. Inside this module, we are calculating engineering value of the voltage from ADC value. We are also raising two faults for over voltage and under voltage protection. We can see that the faults from cell current monitor and cell voltage monitor are odd together to generate a common battery fault. And then we have a temperature monitoring module. Now we will look at battery plant. Inside battery plant, we are using the battery current in ampere to arrive at a SOC value, which is later used using a lookup table here. SOC value is input to this lookup table and the output is open circuit voltage of the battery or the cell. We are also using internal resistance information in terms of an electrical equation to arrive at closed circuit voltage of the battery. This is the voltage that we will see across the battery terminals when there is current flowing through the circuit. And then we are assuming a constant battery temperature, which also tells us that we are not taking into account the detailed temperature dynamics of the battery in this model. We also have two more modules. This is BMS voltage and current sensing. This module is used here to emulate electronic hardware, which converts engineering value into ADC value. And then we have a battery temperature sensor. So in this way, these modules are created separately and then they are integrated on this Collimator canvas so that we can simulate them as a complete BMS system. I hope this video tutorial was useful. Thank you very much.